Now we want to get into something a little bit more complex. How do we determine an equation for a parabola if I don't give you a vertex? Well, with this situation, you're going to have to be given 3 points, because if you only have 2 points, you've got a straight line. You need to have that third point to know how much of a curve you've got. So we're going to have to come up with somehow to relate 3 points and solve out this equation for the quadratic. So we're going to look at y is equal to ax squared plus bx plus c. And what we're going to do is we're going to set up 3 equations with 3 unknowns. We can see right here that this right here is an xy point, this is an xy point, and that's an xy point. And if I look at this equation here, I've got x's and y's, but I don't know my a's, b's, and c's. And ultimately, in the end, I want to know what a, b, and c are to tell me what the equation for the parabola will be. So I'm going to give you a big picture here first, and then we'll go into the steps. What we're going to do is we're going to take this equation, our y equals ax squared plus bx plus c, and we're going to create 3 separate ax squared plus bx plus c equations. One for the first point, one for the second point, and one for the third point. So that's going to be our first step. We're going to create 3 separate y equals ax squared plus bx plus c equations, one for each of the points. Once we do that, we are going to have then a system of equations. 3 equations with 3 unknowns, an a, a b, and a c. And then we're going to solve those 3 unknowns. So we'll start by creating our equations. So first of all, I said we're going to create 3 equations, one with each point. So let's start with the first point. We know the first point is an xy of 6 and negative 10. So x is equal to 6 and y is equal to negative 10. So using this format right here, we're going to use negative 10 and 6. So y is negative 10, a is then 6 squared plus b times 6 plus c. I'm going to take my second point right here, this xy point. My y is 0. My x is going to be 1. So I'll plug in 1 where I have an x. And then finally, my last one is going to be 4, 0. So wherever y, I'll plug in a 0. Wherever I have an x, I'm going to plug in a 4. That looks kind of ugly right there. So I'm going to simplify this into something that you're more familiar with. A 6 squared is the same thing as 36a. B6 is the same thing as 6b, plus c is equal to negative 10. The second equation then is going to be 1a plus 1b plus c is equal to 0. Specifically, these are both 1c's. And then the last one is going to be 16a plus 4b plus 1c is equal to 0. 3 equations, 3 unknowns. And there's many ways you could do this. You could do substitution, you could do elimination, you could use Gauss-Jordan methods of elimination, you can set up matrices. And the way I'm going to do it is I want to set up a matrix and we're going to do row reduction. Now, don't freak out when you hear row reduction because we're going to use the calculator to get us through this. So if I have an equation right here, how do I rewrite this as a matrix? Well, when you write as a matrix, you drop off all the variables and you only keep the leading coefficients. So 36, 1, 16, 6, 1, 4, 1, 1, 1, negative 10, 0, and 0. And we put these little dots right there to separate our coefficients from our answers. We can then go to our calculator and do row reduction. Previously what you did is you'd say, okay, I need to make this be a 1. So I divide everything through by a 36 on the first row. Then here I move down, this has to be equal to 0. I do a row swap, I would multiply through by a constant, add and subtract different rows. Calculator can do all that for us. So if we go to our calculator, let me put it move this over here and put the calculator right there. We're going to go to our main menu, and we're going to go up to matrix. So hit second X inverse, which takes us to matrix, and head over to edit. And this right here is 3 rows by 4 columns. So this is going to be a 3 by 4 matrix of 36, 6, 1, negative 10, 1, 1, 1, 0, 16, 4, 1, and 0. Once I've got that entered, this is very key, make sure you hit second quit, because that will save the matrix, and if you just start typing in other stuff, you might run into the issue where it stores what you typed in into that last position of the matrix. You just want to completely exit out of it. Now we want to do row reduction. And the way we do row reduction is we can go to second matrix, and under matrix there's the math option. And if we scroll all the way down to option B, RREF, that stands for row reduced echelon form, which is the result of row reduction. And then we'll choose the matrix we want to do it to. So there's our simplified matrix. 1, 0, 0, negative 1, 0, 1, 0, 5, 0, 0, 1, negative 4. I'll put those dotted lines back. And as you remember, on the left-hand side, you want to have this diagonal 1 pattern. This is called the identity matrix. The right-hand side, then, are your solutions. The top one is A, so A is negative 1. The second one is B, which is 5. And then C is equal to negative 4. So the equation for this parabola is going to be negative 1x squared plus 5x minus 4. What we do is we plug in A, B, and C back into my original ax squared plus bx plus c. I took my 3 values, my 3 points, made 3 equations with 3 unknowns, and then simplified. Now, just to confirm that I am right, we can actually check our work by going to y1 inside of our graphing portion and going negative x squared plus 5x minus 4, and then go to the table. And let me change my table from what we had on the previous section back to 0 and 1. I just want to make sure these points are here. If I go to 6, I see that it is, can't see that with the light there, but there is 6, negative 10, which is one of the points. The second point was 1, 0, and the third point was 4, 0. So all 3 of those points appear in the table, which means I do have the correct values, and this is the correct equation for the parabola.